Hello dear students, welcome back to the Vidhyalakshmi NEET and JEE Academy. This is Meena, your chemistry teacher. Let's move to our topic. Today I am going to discuss about 20 most important conversion reactions which are repeating in your board exam. So these are very important conversion questions. Conversion questions compulsory you will get 3 mark or 4 mark in your board exam, and these 20 questions are frequently repeating questions. Let's move to our topic. See, first one is conversion of ethanoic acid to 2-hydroxyethanoic acid. See children, whenever conversion question come, there is no rule for conversion question, but a few things you have to keep in your mind. Whenever there is a increase in number of carbon or decrease in number of carbon, then there may be some name reactions involved. Suppose if there is an increase in number of carbon, like think about Wurtz reaction, and other reagent like cyanide and treatment with carbon dioxide, Grignard reagent, about these reagents think in your mind. And whenever there is a decrease in number of carbon, think about like Hoffman bromamide degradation, decarboxylation and such. Now when the number of carbon are same, then just think about the reagents. Let's move to our first question, that is conversion of ethanoic acid to 2-hydroxyethanoic acid. Now what is ethanoic acid? So whenever the name is given, when you are trying to write the structure, always I said you, first you cast the odd root. What is the odd root for this eth? So eth means how many carbon? 2 carbon. And next one is primary suffix. What is this? N. N means carbon-carbon bond is single bond. Next one is oic acid. When they are not informing about the position, that is 1. So here what will write? Double bond OH. Oic acid means carboxylic acid, and remaining valency of carbon satisfied with hydrogen. This is ethanoic acid. Ethanoic acid you have to convert to 2-hydroxyethanoic acid. See same, ethanoic acid means this one. 2-hydroxy means second position you have hydroxyl group, that is OH group, and remaining valency satisfied with hydrogen CH2. Now if I look at my two compound, reactant and product, number of carbon are same. What is difference here? One of the hydrogen replaced with OH group. One of the hydrogen replaced with OH group. Now, in carboxylic acid, we have name reaction. One name reaction, that is Hell-Bollard-Zelensky reaction. That is, otherwise you can say alpha halogenation of carboxylic acid. Because directly one hydrogen we cannot replace with OH group. So we have one name reaction, that is Hell-Bollard-Zelensky reaction, HBZ reaction. What is HBZ reaction? The alpha hydrogen will be replacing with halogen. So alpha halogenation of carboxylic acid. So I am treating with Br2 plus red phosphorus. You can take chlorine also, red phosphorus plus Cl2 or red phosphorus plus Br2. If you are taking, the alpha hydrogen will be replaced with halogen. So what is the alpha hydrogen? See here, this is the C double bond O carbon. Next to C double bond O carbon is alpha carbon. Next to C double bond O carbon is alpha carbon. So the hydrogen attached to alpha carbon are alpha hydrogen. So what I am going to do is, this CH3 I am going to write as CH2H, I am going to write as CH2H. Now this one hydrogen will be replaced with halogen, CH2Br, C double bond OH. Remaining part don't disturb, acidic, keep acidic. So this reaction is known as HBZ reaction. What we are doing? We are doing alpha halogenation of carboxylic acid. That is what? One of the alpha hydrogen we are replacing with halogen. Next step, this halogen converting to OH. We have one reaction, nucleophilic substitution reaction. So I can use here aqueous KOH or NaOH, aqueous KOH or NaOH. What it will do? It will do the nucleophilic substitution reaction. So this one nucleophile replaced with another nucleophile, that is OH. So conversion of, this is the conversion of ethanoic acid to 2-hydroxyethanoic acid. Two step. First step we did alpha halogenation of carboxylic acid, which is also known as HBZ, and second step we did nucleophilic substitution reaction. See, conversion questions involve lot of organic concept. So before solving the conversion question, you should be thorough with all the organic chapters. Then only immediately your mind should think from here to here means which reagent, which reaction, which name reaction. So all those things it should be come in your mind immediately. So for that you need lot of practice of all the organic chapters. Let's move to the second question. Yes. Second question, ethanoic acid to methanamine. Second question is ethanoic acid to methanamine. So again we will write what is ethanoic acid? CH3COOH. What is methanamine? See here, meth means one carbon. So CH3NH2, methanamine. Now this is what carboxylic acid to amine, that also think that also here only one carbon, here two carbon. That means number of carbon decreases in product as compared to reactant. So think just which reactions might come here. So here amine we are getting. From amide to amine one carbon less we have one reaction, that is HBD reaction, Hoffman bromomide degradation. That is from amide to amine. So if we convert acid to amide, then we can get amide to amine which contain less, one carbon less. Am I clear? So very important, just think reverse way. See what you want methanamine, but methanamine directly from carboxylic acid I cannot get. So you think the ways from which compound you can get the methanamine. That also carbon should be reduced. So that is, so immediately in my mind what came? HBD came. So from HBD we can get the amine with one carbon less. Now HBD, that reactant is what? Amide. So then think that compound from the given one reactant how you can obtain. So immediately this, you know already carboxylic acid, if you heat with ammonia, if you heat the carboxylic acid with ammonia, what you will get? You will get amide. How? See here this NH3, shall I write it as a NH2H, NH2H, this OH and this H remove in the form of water, OH and H remove in the form of water. So instead of OH what will let us? Will let us NH2, C double bond O, NH2. So this is what? Amide. Now from amide to amine with one carbon less, already we know what is that reaction? HBD, Hoffman bromomide degradation. What is the reagent for this? Is Br2 plus KOH or NaOH also you can use. If you see in NCERT, I think it is given as a NaOH, you can use KOH also, not a problem. So see, ethanoic acid I convert to amide by treating with ammonia, heating with ammonia, and that ammonia I did Hoffman bromomide degradation. So Hoffman bromomide degradation, when you are doing, just escape this CO, forget this CO, what will come? CH3NH2. So you are getting the amine with one carbon less than amide. Is it clear? I think, please note down. Then we will move to the next conversion question, benzyl chloride to phenyl ethanoic acid. So what is the benzyl chloride? First of all, what is the benzyl group? Benzyl is different from benzene. Remember, what is benzyl group? The carbon attached to benzene ring is benzyl carbon. So here I am writing benzyl chloride CH2Cl. This is what? Benzyl chloride. And what is the phenyl ethanoic acid? So that means ethanoic acid means 2 carbon acid, already you know, 2 carbon acid. Now that means phenyl means benzene ring will be substitute. This is the phenyl ethanoic acid. See, first you focus on this one, root word. What is the root word? Eth, single bond N. So why we did oic acid means for carboxylic acid. Then phenyl as a substitute. So this is what? Phenyl ethanoic acid. Remaining valency you satisfied with hydrogen. Now benzyl chloride to phenyl ethanoic acid. Now you are getting carboxylic acid and you are having here alkyl halide. Now immediately you remember the preparation methods of carboxylic acid. So if I have cyanide or amide, I can do the hydrolysis of cyanide to get the carboxylic acid. And it is very easy to convert alkyl halide to cyanide. That also why I said cyanide, because here see, compared to this compound, here we have one carbon more. So when you have to increase the number of carbon, the cyanide, converting to cyanide is very, very useful and versatile reason. Okay. So converting the haloalkane to cyanide is one of the important steps for increasing the number of carbon. And see here there are only 7 carbon, here we have benzene ring, this one extra carbon. So what I am going to do is, I am going to treat this with either KCN, ethanolic KCN, or you can add with NaCN, KCN or NaCN. You can treat with KCN or NaCN. What will happen? Nucleophilic substitution reaction will happen. Nucleophilic substitution reaction will happen. This chlorine will be substituted by cyanide. Chlorine will be substituted by cyanide. Clear? Now, if I am doing complete hydrolysis of nitriles, or you can say cyanide, what I will get? I will get carboxylic acid. Very, very easy. First we treated with KCN, we converted into cyanide, and cyanide on hydrolysis converted to carboxylic acid. So which is our required product, that is phenylethanoic acid. I hope it's clear. Next we'll go to next question, that is ethanol to butenol. So what is ethanol? It means 2 carbon, N means single bond, Al means aldehyde functional group. So it is what? Ethanol. Ethanol, you have to convert it into, you have to butenol. But means 4 carbon, second position you have double bond, so 2 in, and Al in the first position, that is aldehyde functional group. See, if I look at here, my aldehyde, given aldehyde is 2 carbon aldehyde, and what I have to make is 4 carbon containing aldehyde, that also alpha beta unsaturated aldehyde. That means we have one name reaction. What is that? Aldol condensation. Aldol condensation, we have the aldehydes or ketones having alpha hydrogen in the presence of mild base like dilute NaOH, dilute KOH, or calcium hydroxide, barium hydroxide, like weak base or dilute base, then it will undergo aldol condensation and will give you the alpha beta unsaturated carbonyl compound. So how we will do is, I am going to take 2 moles of this acetaldehyde, or which common name is ethanol. So common name is acetaldehyde and IUPAC name is ethanol. So here one molecule I am writing like this, another molecule write 2 hydrogen this side like this. CH3, shall I write it as a CHH2? It is CH3 only. Another molecule, then C double bond OH. So what I did, the one molecule of ethanol, that oxygen one side, and another molecule 2 alpha hydrogen. Remember, alpha hydrogens are very important. So this 2 hydrogen, 1 oxygen, what I will do? I will remove in the form of water. Then what I will get? See, here it is dilute NaOH followed by heating. So what I will get? See, CH3, same, this CH3, then CH, double bond CH, double bond CH, C double bond OH. So very, very simple aldol condensation. So from one aldehydes, we have removed oxygen, from another molecule 2 alpha hydrogen, very important, 2 alpha hydrogen we removed in the form of water, and simply remaining species if we join, what we got? We got our required product, which is known as but2-enol, but2-enal, okay, but2-enal. So this is our required product, very, very important and easy also. This is aldol condensation. What is this name reaction? This name reaction is known as aldol condensation, simply. So you can try with many other aldehyde or ketone also. For example, I am having CH3. It is not this question, but just I am teaching you how you can write directly aldol condensation product. I am taking acetone. Condition for aldol condensation is the aldehyde should have alpha hydrogen. Aldehyde should have alpha hydrogen. Now I am taking 1 molecule of acetone, oxygen, say I am writing according to my convenient. Then another molecule 2 alpha hydrogen. Now C double bond O CH3. So 1 molecule of 2 alpha hydrogen and 1 molecule of oxygen remove in the form of water. What you will get? Dilute NaOH heating. What you will get? You will get CH3 C double bond CH, C double bond O, CH3, and here we have one more CH3. Understood? So, aldol condensation questions practice like this, you can save the time and easy also. Okay, I think it is clear. Next, let's move to the next question. That is same, reactant is same, ethanol. See, ethanol means alcohol, Al means aldehyde. Remember, OL means alcohol, Al means aldehyde. So, here same aldehyde containing 2 carbon, that is CH3, C double bond O, H. So, ethanol, ethanol. 2, what we are getting? Another our required product is 3-hydroxy butane Al. Okay. So, butane means 4 carbon single bond, Al means aldehyde, and which position you have the substituents? Third position you have hydroxy group as a substituent. So, this is how 3-hydroxy butane L, or you can say 3-hydroxy butanol. So, this is remaining valency you can satisfy with hydrogen 1, 2, 3, 4. Okay, right. Now, see, previous session we did aldol condensation, aldol condensation. See here number of carbon is double, number of carbon is double. So, think about an aldehyde containing alpha hydrogen also, think about aldol reaction. See, aldol means containing here aldehyde functional group and alcohol also. So, aldol. So, our product is aldol. Previous one is alpha beta unsaturated, means that is aldol condensation product. Condensation means after removal of water from aldol, you will get the aldol condensation product. Full mechanism we didn't do, but direct shortcut methods we applied to find out the product. But here, look at here, only we have to do aldol. What we will do, I am treating this with dilute NaOH. If I am treating with dilute NaOH means what? Base Na plus OH minus. Now, base want what? H plus. Now, alpha hydrogens are acidic in nature due to 2 reasons. Due to the electron withdrawing nature of C double bond O group. Another one is after removing alpha hydrogen, whatever the conjugate base you will be getting, that is stabilized by resonance. So, in board questions can come, why alpha hydrogens are acidic in nature? Remember please, alpha hydrogens are acidic in nature means alpha hydrogens you can remove in the form of H plus. So, how it is possible to remove in the form of H plus? 2 reasons. One is electron withdrawing group of C double bond, electron withdrawing nature of C double bond group, which will make the alpha hydrogen as a acidic. And second reason, see, anything want to lose H plus if its conjugate base is stable. Now, after removal of H plus ion, this conjugate base is what? Stabilized by resonance. Because of that reason, alpha hydrogens are acidic in nature. Okay, let it be, this is the extra things. Now, come to our actual topic. Now, when you are treating with dilute NaOH, OH minus base want acidic hydrogen. Which hydrogens are acidic? Alpha hydrogens are acidic. So, shall I write it as a CH2H? This OH minus will take this H plus, these electrons will be shifting over here. So, what you will get? CH2 minus C double bond OH, and here water molecule you will be removing. You will be removing the water molecule. Now, this compound is known as, this intermediate is known as carbanion. Negative charge having on carbon having negative charge is known as carbanion. Now, it can act as a nucleophile. It can act as a nucleophile and can attack at a electrophilic center. So, what I am going to do? I am going to take another molecule of aldehyde, another molecule of same aldehyde. Now, we know very well this C double bond O carbon, carbonyl carbon is electrophilic in nature because of oxygen is more electronegative than carbon. So, what will happen? This nucleophile will try to attack on this carbonyl carbon. Now, carbon cannot form pi bond. So, this pi electron you shift towards the oxygen. What you will get? See, I am writing same CH3 CH O minus CH3 CH O minus, this OH we can write up also, OH O minus, then see this CH2 making the carbon making bond with this carbon CH2 C double bond OH. Now, from the reaction medium from the reaction medium, this O minus will take H plus, then what we'll get? We'll get the required product, which is 3-hydroxybutanol. 3-hydroxybutanol. Okay. So this is what aldol product. Why we are calling aldol, children? We are calling aldol because of two functional group. One is aldehyde, another one is alcohol. So when we treat the ethanol with dilute NaOH, we got carbon ion which can act as a nucleophile, and it will attack on the electrophilic carbon, that is carbonyl carbon is electrophilic carbon, and followed by protonation of O minus, we got our required product, that is 3-hydroxybutanol. 3-hydroxybutanol. Al, not OL, okay, butanol. When we are pronouncing, it is like similar like butanol or all, OL, all. Okay, so butanol and butanol. All means alcohol, Al means aldehyde. I think it is clear. Let's move to the next question. Propane to all. Propane to all. So what is propane? This question also many times, see these all questions are repeated question only. Propene means what? 3-carbon alkene. So first position you have the double bond, and propane to all means 3-carbon, second position you have alcohol. So propene to all. I think we have. So now immediately think about preparation methods of alcohol. So you have many methods of preparation of alcohol, among which from alkene. From alkene you have two methods. One is acid catalyzed hydration, another one is hydroboration oxidation, and one more also there, that is oxymercuration demercuration. So total 3 methods are there from which you can convert alkene to alcohol. Now let's recall first method, acid catalyzed hydration. Acid catalyzed hydration, what we are going to do? We are adding the water according to Markovnikov rule. So look at here, if I am adding the water according to Markovnikov rule, am I getting this product? So what I am going to do? H2O in presence of acid. So Markovnikov rule means you have negative part will attach to that carbon which contain less number of hydrogen. So break this pi bond, break this pi bond, then add OH to this carbon, H to this carbon. Same only now. If I am doing like this, what I am getting? I am getting propane to all. Propane to all. So propene on acid catalyzed hydration, the addition of water will take place according to Markovnikov rule, then we will be getting propane to all. So one more questions very repeatedly they are asking. Second I am giving you propene to propane 1 all. Now when 2 all means we have to add water according to Markovnikov rule, then we are getting 2 all, but 1 all means anti-Markovnikov rule. If you are adding the water according to anti-Markovnikov rule, then what you will get? See here, this is the propene, and propane 1 all means 3 carbon, first position you have the alcohol, Now see here, if I am adding OH to this carbon and H to this carbon, then only I am getting that. What is that? The negative part going to that carbon which contain more number of hydrogen. What is that rule? Anti-Markovnikov rule. So if I am adding the water according to anti-Markovnikov rule, I am getting propane 1 all. So which reagents will do the addition of water according to anti-Markovnikov rule? Tell me, quickly guess. It is hydroboration oxidation. What reagent we have to take? We have to take first reagent as a BH3, then second reagent as a H2O2 in presence of basic medium. So first one is you can take diboron, or this diboron or BH3 you can take, and followed by H2O2, hydrogen peroxide in basic medium. These reagents finally you will get the water, indirect addition of water actually here happening, and according to Markovnikov rule, then you will be getting propane 1 all. I think this conversion also clear. So propene to all means addition of water according to Markovnikov rule, which is acid catalyzed hydration you have to do, and if it is the question propene to propane 1 all, you have to do addition of water according to anti-Markovnikov rule, that is hydroboration oxidation. What are the reagents we are taking? I have written here. Okay. Let's go to the next class, next slide. Next question is ethyl cyanide to ethanoic acid. Ethyl cyanide to ethanoic acid. Now look at here. What is ethyl cyanide? CH3, CH2, CN. What is ethanoic acid? 2 carbon containing acid. CH3COOH. Look at here. Now our reactant contain 3 carbon, product contain only 2 carbon. That means there is a decrease in number of carbon while we are moving from reactant to product. Now if we are having same number of carbon, you can easily convert it. How? Just before also we did. What is that? Hydrolysis of cyanide will give you the carboxylic acid with same number of carbon. But here, what is the problem over here is the number of carbon here which we require in carboxylic acid is less than the number of carbon which is present in cyanide. So what we'll do? First we'll convert into acid only. Hydrolysis of cyanide will give you the acid. So CN will convert into COOH. Now carboxylic acid. Yes. Now if I heated this with ammonia, what I'll get? I'll get amide. Now why I am going to amide side? Because I have to reduce the number of carbon, and you know very well Hoffman bromamide degradations, by using that name reaction we can decrease the number of carbon. So I am going to amide to amine and amine to alcohol. How? If you are taking aliphatic primary amine, reaction with nitrous acid will give you alcohol. Remember, if you are taking aromatic primary amine, you will get benzene diazonium salt. So if you are getting aliphatic primary amine, we will get alcohol. Now if I am doing Hoffman bromamide degradation, Br2 plus NaOH, what is this name reaction? Hoffman bromamide degradation. What will do? Just escape this CO. What you will get? CH3, CH2, NH2. So amine with 1 carbon less. Now if I am treating this amine with HNO2 nitrous acid 0 to 5 degrees centigrade, what I will get? I will get CH3, CH2, OH alcohol, primary alcohol. Now you know very well, primary alcohol to carboxylic acid, you can convert primary alcohol to carboxylic acid by using strong oxidizing agent like, tell me, guess, KMNO4 in acidic medium, K2Cr2O7, John's reagent, nitric acid, any of this strong oxidizing agent you can use to convert primary alcohol to carboxylic acid. So this many steps involved. See children, conversion questions are like this. Some conversions may be 1 or 2 steps, some conversions may be many steps conversion. So you have to do very carefully. Okay. Please note down this. Next we will move to the next question, conversion of aniline to phenol. See, most of the aromatic compound, whenever you are you have to convert to aromatic compound, think about benzene diazonium salt. Benzene diazonium salt is a mother of many of the aromatic compound. So not 100%, but many times it will be like via the benzene diazonium salt. So what is aniline? Aniline is primary aromatic amine, NH2, this is aniline. Now you have to convert this into what? Phenol. You have to convert into phenol. So I told you, most of the aromatic compounds will be converting via benzene diazonium salt. What I am going to do? I am going to convert aniline into benzene diazonium salt. I think you know very well diazotization reaction. What we'll do? We'll treat with nitrous acid HNO2. Instead of HNO2, many times you will be seeing the HCl plus NaNO2, same meaning. Since nitrous acid is highly unstable, we cannot store it. So during the reactions time itself, we will be mixing HCl plus NaNO2 to prepare the nitrous acid, and very low temperature 0 to 5 degrees centigrade, what we'll get? We'll get benzene diazonium salt. So this is our what? This is our benzene. This is our benzene diazonium salt. Benzene diazonium salt. Now you know very well, this is the one of the preparation methods of phenol. Benzene diazonium salt, if you warm with water, what will happen? You will get the phenol. How? See, water shall I separate it into H plus, OH minus, H plus, OH minus. Now this H plus and Cl minus will remove in the form of HCl, and this N2 will liberate in the form of nitrogen gas. So what will happen? The OH will attach over here, then we will get our phenol. Okay. So, here water, when we are heating with water, the H plus Cl minus will remove in the form of HCl, nitrogen N2 will liberate in the form of N2 gas, and this what is remain ma? OH is remain, that will attach to benzene ring and will get our phenol. So, this is another conversion question, aniline to phenol, and important also. All are important, these 20 are very very important. Next we will move to next question, 9th, aniline to chlorobenzene. What is this? Chlorobenzene. Here one name reaction. See children, simultaneously remember name reactions, very very important. From name reactions the questions can come directly as well as indirectly. Indirectly they can come in the form of conversion also. You might be seeing in many conversions we are using many name reactions. So, name reactions are very very important. So, let us move. What is aniline? Again same, aniline, primary aromatic amine. What is the chlorobenzene? So, benzene attached with chlorine, or chlorine attached to benzene is chlorobenzene. See, again same thing, we have to convert into benzene diazonium salt, that is N2 plus Cl minus, by treating with HNO2 at very low temperature 0 to 5 degrees centigrade. Now, if I treat this benzene diazonium salt, you have two name reactions. One is Sandmeyer reaction. By a Sandmeyer reaction also you can, through Sandmeyer reaction also you can prepare, or through Gattermann reaction also you can prepare. What is the difference in these two? In Sandmeyer reactions we will be taking the salt of copper, but in case of Gattermann reactions we will take the copper powder, that is it. In Gattermann we will take the copper powder, in Sandmeyer we will take the copper salt. So, I am taking CuCl in the presence of HCl. So, copper salt, copper chloride in the presence of HCl. Some books they are giving you Cu2Cl2, same thing, no need to confuse. Okay. So, this is our, this name reaction is what? Sandmeyer reaction. Sandmeyer reaction. Okay. So, we can prepare chlorobenzene from benzene diazonium salt by using either Sandmeyer or Gattermann reaction. Here I am using Sandmeyer reaction. The yield will be good in Sandmeyer reaction compared to Gattermann reaction. Okay. Note down. Next we will move to next question, that is 10th one. 2-bromopropane to convert 2-bromopropane to 1-bromopropane. See, same number of carbon, only what is the difference? Propane means 3 carbon and second position you have bromine. 1-bromopropane means propane is 3 carbon but bromine is first position. So, what I can see over here is number of carbons are same. What is the difference? The position of the substituents is difference. In first case we have in second position, second case we have in first position. Am I clear? Now, see, so here everything only position difference. See, from this is what haloalkane. Shall I convert into alkene? Alkene. From alkene again we can prepare the haloalkane. Haloalkane by elimination of HBr I can convert into alkene. Then alkene addition of HBr again I can convert into haloalkane. Now, what is problem? Here we can do the peroxide effect, or you can say anti-Markovnikov rule. You have to do addition of HBr according to anti-Markovnikov rule to form the 1-bromopropane. I think you got idea. First you convert this into alkene. You can take alcoholic KOH or NaOH. What we'll do? We'll remove the hydrogen and halogen from adjacent position. See here, this is the carbon to which halogen attached. So, that halogen plus adjacent carbon. Adjacent you have 2 carbon, either this or this. You can remove from any one, no problem, same thing. So, if you want to remove from here, you can remove, it is the same product you will get, not a problem, not a issue. So, what I am going to do? I am going to remove the hydrogen and halogen from the adjacent carbon. This reaction is known as dehydrohalogenation reaction. Elimination reaction. Dehydrohalogenation reaction means halogen and hydrogen we are removing HBr. Then if you are removing, what you will get? You will get the double bond between them. So, from carbon where you are removing the hydrogen and halogen, between those carbon you will get the double bond. Now, if I am doing addition of HBr in the presence of peroxide, what you will do, children? You will add the addition of HBr according to anti-Markovnikov rule. If I am not taking peroxide, then it will obey the Markovnikov rule. Remember, if I am adding peroxide, what rule you will follow? You will follow anti-Markovnikov rule. So bromine will attach to this carbon which contain more number of hydrogen, and hydrogen will attach to this carbon. See here. So if you apply over here, I will break this bond, I will add bromine to this and hydrogen to this. So this is which rule we are following? Anti-Markovnikov rule. Anti-Markovnikov rule. Anti-Markovnikov rule. I think it's clear. So we got our required product, which is 1-bromopropane. 1-bromopropane. Now let's move to the next question. Next one is propanone to propene. So propanone is what? Ketone, like 3 carbon containing ketone, C double bond O CH3. Common name is acetone. Common name is acetone. So propanone, you have to convert into propene. Propene means alkene, like this. Okay, alkene. Now think, from aldehyde to alkene, sorry, from carbonyl compound, that is ketone to alkene, I think we don't have method. But if we can convert it into alcohol, and if you are doing the dehydration of alcohol, then you can get the alkene. So come from reverse. Alkene you can prepare from alcohol. So convert this ketone into alcohol. So what I am going to do? I am going to do reduction of this propanone, or which is known as acetone, by using sodium borohydride. You can use 3 reagents for the reduction of ketone and aldehyde. One is sodium borohydride, another one is lithium aluminium hydride, and another one is hydrogen in the presence of nickel, platinum or palladium. So what we will do? We will do, see, very easy. It will provide the hydrogen. Here I will break this bond, H over here, H over here. What I will get? CH3, CHOH, CH3. This is our alcohol. Now if I am doing H2SO4, so this is a secondary alcohol. You don't need to take full concentrated H2SO4. If you are taking somewhat less concentration also, okay, it can do the elimination. Now what we are going to do? We are going to dehydration. Dehydration means elimination of water. Elimination of water. How we will do? See here, this carbon, the OH attached to one carbon, and from that OH and adjacent carbon, from adjacent carbon you remove the hydrogen in the form of water. From adjacent carbon hydrogen and the OH from the carbon. So the carbon to which OH is attached, that you focus on adjacent carbon. From adjacent carbon hydrogen, from that carbon OH remove in the form of water. So what you will get? You will get the alkene, which is a required product in this question. Am I clear? So we can go to the next question. Phenol to anisole. Here also one name reactions will involve. Phenol to anisole. So what is the phenol? Phenol. What is anisole? What is anisole? OCH3. So this methyl phenyl ether is known as anisole. Methyl phenyl ether is known as anisole. Now, one name reaction, do you remember Williamson synthesis? How can you prepare Williamson synthesis? What you will prepare in Williamson synthesis? Sodium alkoxide react with alkyl halide will give you ether. Now, see, shall I convert it into alkoxide form? Like here phenoxide, because it is a benzene, then we will get phenoxide. If it is a normal alcohol, we will get alkoxide. Now I am treating this with NaOH. What I will get? I will get sodium phenoxide. Sodium phenoxide. O minus Na plus. It is my sodium O minus Na plus. Sodium phenoxide. Now we got the alkoxide ion. Next, what is the another reactant we require in Williamson synthesis or ether synthesis? We require alkyl halide. Now, how many carbon extra we require other than this? One carbon. So, take alkyl halide containing one carbon. So, I am taking methyl chloride. I am taking methyl chloride. So, what I am going to do over here is, see, methyl chloride I will write like this, ClCH3. Now, remove this NaCl, remove this NaCl. So, instead of Na, what you will write? Methyl group. So, we will get our anisole, which is our required product. So, phenol, this question is many times asked in NEET also. So, phenol treat with NaOH, convert into phenoxide, and that treat with methyl chloride, bromide, you can take anything, then you will get the anisole. How the questions came? like direct conversion like this. Another one, what are the correct set of reagents to prepare anisole? Correct set of reagents to prepare anisole. So please note it down. Ethane to butane. So one more reaction, chloroethane to butane. Here name reaction, you are getting alkane from alkyl halide, that also double the number of carbon. Chloroethane means C2H5Cl and butane means C4H10. Direct name reaction, tell me which name reaction. Do you remember Wood's reaction Rx when we are treating with sodium in the presence of dry ether? What will get? RR, double of the carbon, alkane containing double carbon. Same thing now. So here which reactions we are applying? By treating with sodium in presence of dry ether. This our reaction is what? This reaction is known as Wood's reaction. This reaction is known as Wood's reaction. Okay, Wood's reaction. Very, very easy. Chloroethane to butane. What? Single step conversion by using the Wood's reaction. Next we will move to the next slide, that is chlorobenzene to 2-chloroacetophenone. Here also direct one step reaction. What is chlorobenzene? This is chlorobenzene. And what is 2-chloroacetophenone? Acetophenone is like benzene ring COCH3 and 2-chloro means like this. See, very, very easy. What we will do? Friedel-Crafts acylation. COCH3. See, like it is a acyl group or not? C double bond OR, acyl group. Right. So here I am going to do Friedel-Crafts acylation. What we will do? Cl, C double bond O, CH3. I am taking acid halide. I am taking acid halide in the presence of AlCl3. In the presence of AlCl3. See, chlorobenzene I can write here also, no problem. Right. Chlorobenzene like this also I can write, right? Chlorobenzene. Now what will happen? This is a electrophile. So here from here ortho and para, you will get the two product, but our questions here only one asked, so we will do only one. But actually you will get two product over here when you are doing Friedel-Crafts acylation, you will get ortho product and para product, but here only ortho is given. So at ortho position, the H+1 electrophile will replace with this acyl group. So which is another electrophile. So it is an example of electrophilic substitution reaction. So what you will get? This product as 2-chloroacetophenone. Next we will move to next conversion, that is benzoic acid to benzaldehyde. So what is benzoic acid? Benzoic acid is benzene ring COOH. What is benzaldehyde? Benzaldehyde is benzene ring and CHO. Now, just recollect the preparation methods of aromatic aldehyde, that is benzaldehyde. So we have one Itard reaction, we have Gattermann-Koch reaction, that is from benzene. Then we have another reaction, that is Rosenman reduction you have, that is acyl chloride you can convert into aldehyde. So shall I convert this carboxylic acid, that is benzoic acid, into benzoyl chloride very easily. Then benzoyl chloride, if I do the Rosenman reduction, I will get what? Benzaldehyde. So very, very easy. You can do Rosenman reduction also, you can do diol H also. So you will get the benzaldehyde. See here, I am treating with SOCl2. Simply what you will do, children? This OH you will replace with chlorine. OH you will replace with C double bond O, Cl. This is known as benzoyl chloride. Okay. Now here you do the Rosenman reduction. What is the Rosenman reduction? Pass in hydrogen gas in the presence of Lindlar's catalyst. What is Lindlar's catalyst? Palladium barium sulfate. Palladium barium sulfate. So this is also one of the name reaction, conversion of acid halide, acyl chloride, whatever you say, to aldehyde. So this is what Rosenman reduction. We get two steps only. Benzoic acid convert to benzoyl chloride by treating with SOCl2, which you do the Rosenman reduction, you will convert into benzaldehyde. So next we will move to next name reaction, so next conversion reaction, benzoic acid to aniline. Benzoic acid to aniline. What is our benzoic acid? This is our benzoic acid. What is the aniline? This is our aniline. So how we will convert benzoic acid to aniline? That also one carbon less. See here, here you have NH2. one carbon less here compared to reactant. So immediately remember one name reaction. What is that? Your product is amine and one carbon less means immediately you remember name reaction Hofmann-Bromamide degradation reaction. And for Hofmann-Bromamide degradation reaction, what is your reactant should be? Amide. So convert carboxylic acid to amide and do the HBD, then you will get the amine. That's it. Very easy. Already you have done before also. So what I am going to do, I am heating with ammonia. Same thing previously I have explained you. When you are heating with ammonia, this OH, and from ammonia one hydrogen replace in the form of, so remove in the form of water. So OH will be replaced with NH2 group. So what you will get? You will get benzamide. You will get CONH2. So here COH. So this OH, H remove in the form of water. Then instead of OH, what you will get as NH2. Now from here HBD means treating with Br2 and NaOH. This is name reaction, many times repeating, see children, many times. Whenever there is a decrease in number of carbon and you need the amine, that time we are applying HBD, Hofmann-Bromamide degradation. Okay. Next we will go for next conversion, that is propane to all to 2-methyl propane to all. That means alcohol to alcohol only. What is difference over here is propane to all to 2-methyl propane to all. See same only, what is this? One extra methyl group have been added, and this is which degree alcohol? Tertiary alcohol. Now immediately remember children, whenever your product is alcohol and you are having tertiary, secondary such alcohol, remember about Grignard reagent reaction with carbonyl compound. If Grignard reagent react with formaldehyde, you will get primary alcohol. If Grignard reagent react with all other aldehyde except formaldehyde, you will get secondary alcohol. If Grignard reagent react with ketone, you will get tertiary alcohol. Now R is what? Tertiary alcohol. That means we need ketone and Grignard reagent. But what is our reactant? Our reactant is secondary alcohol. So what I will do, I will convert this secondary alcohol into ketone. I will convert the secondary alcohol into ketone by treating with oxidizing agent. You can use mild oxidizing agent as well as strong oxidizing agent in order to convert secondary alcohol to ketone. Here I am using PCC, PDC, KMNO4, K2Cr2O7, John's reagent, any oxidizing reagent, either it is a strong or mild, you can use in order to convert secondary alcohol to ketone. So what I will do, I will remove this hydrogen, see this H and this H, remove in the form of H2 and put a double bond between carbon and oxygen. What you got? You got ketone. Now ketone, when I treat with Grignard reagent, now just look it over here. See this is my 3 carbon. Here one extra methyl group you have. So what is the extra alkyl group you have? Same carbon containing Grignard reagent you take. So R of the Grignard reagent should be methyl. Why? Here we have one extra methyl group. That's it. So I am taking over here CH3MgBr. So what will do? This alkyl part will be what? Nucleophile. It will attack on this carbon. That time this electron will be shifted towards the oxygen. Then what I will get? CH3 CO minus CH3 acetic. This CH3 of what? Grignard reagent. Here O minus MgBr. If you want to write, write. If you don't want, no need to write. Right? Now next hydrolysis. If I am doing hydrolysis, I am doing. So what will happen? Water you have H plus, OH minus. This Mg plus will take OH minus. This O minus will take H plus. So what you will get? The byproduct MgBrOH. You don't need to write over here. Directly when you are doing hydrolysis, this O minus will accept the H plus and will be getting the alcohol. So secondary alcohol to tertiary alcohol they gave conversion. Directly we cannot do anything. Secondary alcohol we converted into ketone. Ketone react with Grignard reagent followed by hydrolysis. We got tertiary alcohol, and this reaction is also very important, not only in conversion reaction, in many complete the following or in conversion form. Many things they can ask you. Convert methyl magnesium bromide to 2-methyl to propanol. So immediately you think Grignard reagent and carbonyl compound combination. If they are asking you to prepare the alcohol, and that also you just find out the degree of alcohol and accordingly you think which you have to use. Am I clear? So next we will move to next conversion, that is 18th number conversion. Benzene to phenol, very easy conversion. What is our benzene? See, here also one name reactions will involve. See, in industrial methods of preparation of phenol, what is that method? Industrial method of preparation of phenol is what? Dawes process. So Dawes process, what we will do? We will convert chlorobenzene. We will convert chlorobenzene to phenol. How? By treating with aqueous NaOH at very high temperature of 623 Kelvin and pressure of 300 atm, followed by acidification. What you will get? You will get the phenol. This is the industrial methods of preparation of phenol. This process is known as Dawes process. This process is known as Dawes process. Now, from benzene to chlorobenzene, how can you prepare? Very easy. Halogenation like Cl2 in presence of AlCl3, electrophilic substitution reaction, that is what? Halogenation of benzene. Even 11th class you have studied, in 12th class also many times it is repeating. So benzene we convert it to chlorobenzene, chlorobenzene by using Dawes process we convert it to phenol. One more methods also you can use, please try that method, even it is given in NCERT, via benzene sulfonic acid. Convert benzene to benzene sulfonic acid by doing sulfonation, and benzene sulfonic acid, same setup reagent like aqueous NaOH, high temperature pressure, you can convert that into phenol. Please write in your notebook another method, any one you can use, both will be correct. Next we will move to next conversion reaction, that is benzene to aniline. Benzene to aniline, very easy method. Now tell me, preparation of aniline or amine, preparation of amine, if you think, the first method given in NCERT is what? Reduction of nitro compound. So if I am doing reduction of nitrobenzene, what are the reagents that can do reduction of nitro compound to amine? You have three reagents. One is Fe plus HCl, another one is Fe, or you can use tin plus HCl, or you can pass hydrogen gas in the presence of nickel. Any one of these reagents you can use to convert nitrobenzene to aniline, or in general nitro compounds to amine. But among these, what is the best method? Best method is iron plus HCl. Why? Because the FeCl2 byproduct form will undergo hydrolysis with water and will give you the HCl. So HCl will be regenerated. So initially if you take small amount of HCl, that will be enough for the reaction. So economically FeHCl is a best reagent for conversion of nitro compound to amine. So here nitrobenzene to aniline. Now you know very well benzene to nitrobenzene. How will you convert benzene to nitrobenzene? Nitration of benzene. What is the nitration mixture? Concentrated HNO3 plus concentrated H2SO4. What is the electrophile over here? Electrophile over here is NO2 plus. So H plus from benzene will replace by the electrophile NO2 to give the nitrobenzene. Next we will move to next conversion question, and our last conversion question, that is benzene to meta-nitro-acetophenone. So what I am going to do is, first I am converting benzene to acetophenone. How can I convert benzene to acetophenone? By Friedel-Crafts acylation. So I am treating this with acid chloride in the presence of AlCl3. What will happen? Electrophilic substitution reaction. One of the H plus ion will replace by this electrophile. You will get the acetophenone. Acetophenone, if I am doing nitration, con HNO3 plus H2SO4. Now this COCH3 group is what? Meta-directing group. This is electron withdrawing group, which will withdraw the electron density from benzene ring, so that electron density at ortho and para position will decreases, so that incoming electrophile will attach at meta position. Similar kind of reasoning questions can come in board exam. why benzoic acid is meta-directing, why benzaldehyde is meta-directing. Same reason you have to say, children. These are what? Electron withdrawing group which will withdraw the electron density from benzene ring and they will decrease the electron density more at ortho and para position. Here I am not drawing the resonating structure. If you draw the resonating structure, if there is a electron withdrawing group, ortho and para position you will get the positive charge. That means electron density at ortho and para position decreases. So incoming one is what? Electrophile, which is electron deficient. Now electron deficient want electron rich place or electron deficient place? Obviously it want electron rich place. So compared to ortho and para position, meta position not getting any positive charge. So compared to that position, meta position is somewhat electron rich. As a result, incoming electrophile will attach at meta position. So these groups are what? Meta directing groups. So please note it down. Electron withdrawing groups are attached in benzene ring, means those are meta directing groups. Why reason you have to say? That decreases the electron density at ortho and para position. As a result, they will direct the incoming electrophile at meta position. Now if I am doing here nitration, so this is also example of electrophilic substitution. What is our electrophile? NO2 group. So here you will get meta nitro acetophenone. So here you will get meta nitro acetophenone. Okay, that's all for today. So these are the 20 most important conversion question. Please practice it and repeatedly practice it, so that not only like you should not mug up the reactions, you have to get idea. So just I gave you some hint, like number of carbon decrease means you think about Hoffman bromide degradation or decarboxylation, etc. Increase means you think about the reagent which will increase the number of carbon, or name reactions where number of carbon have been increased, and so on. So all the best, study well, see you in next video. Thank you.